Classroom management is an important part of all science lessons. At SBSM Independent School in Lenasia, the teacher, Dr. Curti Beecher, is beginning a lesson on acids and bases with a grade 10 class.
Right, today we're going to do 3 different chemical tests on 5 different substances. Now we don't know what the 5 different substances are, so you should handle all these chemicals with care.
The outcomes for the learners are to use existing knowledge of acids and bases to identify which of the substances tested show acidic behavior, and to recognize that substances identified as acids show acid behavior only when dissolved in water.
The 3 tests, I've got them on the board. Test 1 with blue litmus. Test 2 with magnesium. Test 3 with powdered calcium carbonate.
After introducing the subject, the teacher gets learners to discuss these tests with other learners in their groups.
Litmus.
Learners discuss this in their groups. The teacher walks around and interacts with the learners.
Teachers must, in fact, now be seen as facilitators. They make it possible by creating good conditions, perfect, optimum conditions for their learners to construct their own knowledge.
Blue litmus paper turns red when a substance is acidic.
It serves as an indicator to test the substance.
What kind of substance?
Like a chemical substance.
A good interaction involves the teacher listening on the sidelines. She'll make suggestions and ask questions, but will not give them the correct answers.
It's important that you lead the children and not feed them with the correct answer. And in discussions, you can always pick up if they're going in, off in another direction. But you can always bring them back, which is good in that they are thinking about the exercise. What is it made of?
Kind of a paper that tests for.
When the teacher has heard their discussions, she will summarize for the whole class what she has judged to be the important points.
Right, what is litmus? It is a paper that is dipped in a litmus solution and then dried. What is the color of blue litmus in acid?
Ma'am, it turns red in acid.
So blue litmus turns red.
The teacher explains that litmus paper is an acid-base indicator which changes color when dipped into a solution of an acid.
Acids react with some metals, and magnesium, we know from grade 9, is a very reactive metal. It is this gray-white metal piece. Do we all know what is the gray-white on the covering on magnesium?
Magnesium that reacts with oxygen in the atmosphere.
Sandpaper.
The teacher explains that the magnesium oxide must be removed using sandpaper.
In your groups, I want you to discuss what happens when metals react with acid, what products are formed, and write a word equation. What is metal plus acid?
Hydrogen.
Gives you salt?
Hydrogen.
Are you sure? You got your reaction. Acid and metal gives you?
During a lesson, the teacher should not always call on the same group to answer her questions. This ensures that all groups work consistently and are ready to participate all the time.
One of you need to go and write this on the board. Acid and metal gives you salt and hydrogen. What is hydrogen?
Hydrogen is a gas.
Again, in your groups, I want you to discuss what products are formed when an acid reacts with carbonate.
Products of a reaction between acid and carbonates is salt, because between the metal, and carbon dioxide from the carbonate, and water from the reaction between oxygen and hydrogen.
How do we know carbon dioxide is formed?
You can test it by the clear lime water will turn milky.
And for water, we use anhydrous copper sulfate, will turn blue.
When learners have completed the table on the board, the teacher introduces the next activity, the practical tests.
Each group will be given 2 substances. One group will get substance A, substance D, and substance E. The next group will get
The teacher gives each group one of the solids and both of the aqueous solutions to test. She knows that all of the solids behave in the same way in all of the chemical tests.
There are 5 different substances and 3 different chemical tests for acids have to be done on each of those 5 substances. Now, if each group did each of those 15 tests, the practical would take an extremely long time. And what the teacher has done is she's given different substances to different groups and put a table on the board, and the different groups will fill in their findings, their observations and their interpretations on that table on the board. And so it is a great time-saving strategy because obviously she needs all those 5 different substances in order to draw valid conclusions.
Here's a worksheet to show you exactly how the 3 tests are going to be carried out.
Giving only one worksheet to each group forces the learners to work together rather than on their own.
Right, choose one learner in your group to be a reader, one learner in your group to collect the chemicals,
By allocating responsibility, the teacher is ensuring that all learners in each group participate fully in the lesson.
I'll take down the records.
The idea is to get those that are the more introvert and shy more involved, because there is a tendency for children, the brighter ones especially, to take over control of the group.
The teacher does not issue equipment or chemicals to the groups until she is sure that they are ready to start the practical. Learners are often distracted by and fiddle with the equipment and chemicals if they are issued too soon.
3 groups going to collect equipment, the rest of use chemicals, and then...
When preparing for the practical, the teacher places the chemicals on one side of the classroom and the equipment on the other side. This is to allow easy access and is important especially in small, overcrowded classrooms.
The first one is put 3 microspecial substance C into well F1.
Whilst the learner reads the instructions, the other learners execute them.
Push a piece of dry blue litmus into the powder. Remove the blue litmus paper, look for any color change, and then record your observations in the table below.
Learners observe that there is no color change. This is written on the table on the board.
Users request to add water.
In the next part of the test, water is added to the same substance and stirred. The resulting solution is tested with blue litmus paper.
After we added the water, it became acidic, right? Because when there was no water, there was no change of color.
In this test, blue litmus paper turns red only when water is added to the solid substance.
Sandpaper the magnesium ribbon until it is shiny.
See bubbles.
Put 3 micro spatulas of substance A or B or C into well F2. Push the piece of magnesium ribbon into the powder.
Yes, but there was no smell and there was no bubbles inside, so no gas is produced.
Next, a solution of the substance is prepared by adding a few drops of water to it.
Push the shiny piece of magnesium into the solution in well F2.
A bubble reaction occurs. Do you smell anything? No, I can't smell anything. What does this tell us? A gas is formed when a piece of magnesium is placed into the solution.
In this test, learners observed a gas being given off only when a solution of the substance was tested, not when the solid is tested.
Put 3 microspatulas substance A into well F. Add 3 microspatulas powdered calcium carbonate. Stir with a toothpick to mix the solids thoroughly. Record the observations in the table below.
There's no reactions taking place.
Again, water is added to the solid substance. It is stirred, and then calcium carbonate is added.
Record your observations in the table below. There was like a crackling sound, and we've seen bubbles as well.
There was a foul smell.
A gas was produced when the solution was placed on the calcium carbonate.
In this part of the practical, 2 aqueous solutions will be tested for acidic behavior. Here, the learners are not following instructions from the worksheet. They are planning how to do the investigation themselves.
Where's test 2?
Blue litmus paper with substance D.
In the first test, blue litmus paper is put into the aqueous solution.
We observed that the blue litmus paper turned red, which proves that substance D is an acid.
Next, magnesium is put into the same substance.
We observed that magnesium with substance D, there is no reaction.
Did you clean your magnesium with sandpaper?
After being sanded down, the magnesium is again put into the solution.
Bubbles is forming and there is a smell. This tells us that when we mix magnesium with substance D, a gas is produced.
For test 3, carbonate is mixed with the aqueous solution.
Was it necessary to dissolve the calcium carbonate in water?
It wasn't necessary because we would have dissolved it in substance B.
Because substance D is a
Liquid.
liquid. Is there a reaction there?
Yes.
What do you see?
Small bubbles. Calcium carbonate plus an acid will give us salt, water, and carbon dioxide.
So what are those bubbles?
Carbon dioxide.
Carbon dioxide.
It is important that equipment is cleaned after practical work.
Teachers say they don't want to do practical work because they've got to clean up all this stuff afterwards. Well, of course, that is quite wrong. Teachers must train their learners to clear up afterwards. And the monitors return the stuff to its correct place in the correct cupboard.
You have done 3 tests. The summary of your results appear on this table. What do we notice?
Okay, water played an important role in each test because only after you added water to the substance could you test whether it was acidic or alkaline.
Why do we require water?
Ma'am, it needs to be a solvent in order
It has to be in an aqueous solution.
In conclusion, the teacher reveals the identities of the substances tested.
The substances you have tested are all called acids.
These are oxalic acid, citric acid, tartaric acid as the solids, and hydrochloric acid and vinegar as the aqueous solutions.
What I learned is wrong perceptions can be picked up very quickly.
Learners quickly realized that to show acidic behavior in the 3 tests which they did, it was necessary to dissolve the substances in water. But there's a difference between being called an acid, as all of the solids are, and behaving like one.
Hi everyone, now that we have observed the lesson, let us talk about it. At the studio today, we have Liz from VETS, and then we have Andrew from Protect and Kanye from the Science Education Project. Yeah, welcome. Let's talk about this lesson. Firstly, let's look at the facilitation skills that the teacher used in the teaching of this lesson. Are there anything that you'd like to say about the way in which this lesson was facilitated?
I think the teacher obviously planned the lesson very well. She organized, she decided how she was going to use the groups, how she was going to give roles to the groups that will make sure that every activity is paced. And in between each activity, she was collecting ideas from each group. And she was also guiding the progress of the lesson without telling them the answer. Like she would hint into, haven't you forgotten some precaution you're supposed to take? And then the learners will come up and then do whatever they have to do. Example, when they had forgotten to clean the magnesium strip and they were not getting results. So I think she had planned it very well.
Yes. I think, Tembi, if I may come in there,
yes,
that also the fact that the way she used the handouts were very good. And she put some thought into that as well. Make sure that each group got one handout, and that the group, within the group, there is participation and people would work together within the group. And one of the critical outcomes, as we know, for curriculum delivery is basically to get people to learn how to work in teams and groups. And so I think it's a good initiative that she took there. Also in the equipment, she managed that very well, because she decided that she wasn't going to hand out all the equipment, you know, simultaneously. Because what I have seen, and this has actually happened even in cases where I have done experiments, I can recall, where I've given all the equipment and the learners ended up doing all sorts of other things with testing out the equipment and so on. And you can very easily lose control of the class at that point. So I think that was a very critical decision to take, and it was very important and was pivotal in giving the classroom management some real good focus.
She also had that record table on the board.
Yes.
And she had given clear instructions at the beginning. So learners would just get results, go write it on the board for everyone to see. I think that was a very good strategy.
That was good. There was a very important aspect of management, you know, was the Blackboard organization, which helped her to keep control of what was happening and how things developed.
And it was shared with the learners, because learners also had to go and write their responses on the chalkboard.
Absolutely.
One of the things that happened during during her facilitation skills, when the learners were working in groups, she moved around asking questions. And then one of the things that she asked, she said, how do you know that the gas that is formed there is carbon dioxide? Because learners said it's a gas. And then her question was, how do you know that the gas is formed is carbon dioxide? And how do you think about that, of her probing questions to the learners?
I think she did it really well, because she obviously spent time with different groups and posed relevant, pertinent questions in the groups.
And in most cases, those questions were to help them recall their previous knowledge and bring it in to the lesson and link it with what they were doing currently.
Do you usually see this type of strategies taking place in some of the lessons that you see in our schools?
Like in schools where people have been encouraged to do more of lesson preparation prior to the lesson. Then the teacher is more in tune with what he or she is doing, what previous knowledge links to this current lesson. Otherwise, they're sort of overlooked and then given maybe later as application questions.
Yes, I think Konya's right, because it seems to me that the more confident the teacher is with the subject matter, the more they're able to interact with the learners in the groups. If a teacher is feeling a little insecure themselves, they're not so keen to ask questions.
So it's a matter of being confident with your subject matter and also the thorough preparation of your lesson. If we can look at what happened at that lesson, the teacher had already marked some apparatus that were going to be used and actually were put on the side, and she knew exactly how many groups were going to be there and what is it that they were going to do. What do you think about the idea?
That was quite crucial, like Andrew had said. She had put the apparatus on one side and the chemicals on another side. And also she had a strategy on how they were going to get it. She had 3 groups go to the practicals while the other 3 go to the chemicals. After some time they would swap, so that she knew that every group had taken exactly what they need and not any others. Because in this lesson she had given the groups different chemicals as well. So it was very important that a particular group take what has been prepared for them and not what belongs to another group, which is just evidence of preparation. I wonder if she had any other lessons besides this on this day.
Yes, and I think that's a very important point, because what I find from experience working with some of the schools is that teachers don't have time to prepare for lessons. And some schools have asked if they could be assisted with lab technicians, in fact, because this is a typical sort of scenario where you can be that organized if you've got someone else who's actually prepared things for you, and you're moving out of one class, say mathematics class. Most teachers of science teach both science and maths, and they've got a full program for the day. They might be moving out of one maths class into this particular class. It would be wonderful if everything is laid up and everything is prepared for them beforehand. But of course there's a cost factor to be contemplated always.
Yes.
So what can you say about then the cleaning of the materials at the end by the learners?
I was going to say that at least at the end they had put everything back in the right place. The groups had cleaned up very well. This is obviously a very well-resourced school,
yes.
But I think it's possible to do that even if one doesn't have a laboratory to work in. They had water on tap there, but one could work with an ice cream tub with water in, and the learners could rinse the equipment out.
Yeah, because some of the schools don't even, you know, some of the labs are not functional. They don't have running water within the lab itself. And then, you know, one could improvise like that, yes. My own experience has also been that in some of the schools, the micro kits are not being used. And the reason is that they were used, but they were never really put back in order. And so everything got very mixed up and so on. And so teachers got very discouraged. You find them in a sort of corner, wiped away, you know, swept away or put away like that. And they're not being used very well. And I think this is something that we need to look into as to how we can actually get them out of the cupboards again and get some of the teachers to use them more effectively.
But another point that we can learn from this teacher was her time management. Because if someone uses this and has no time built into the classroom lesson to have it washed and packed away, then that's how they learned mixed. You know?
Is there anything that you'd like to comment about in this lesson?
Well, Timby, I'd like to say that you know, when she started off about litmus paper, she was very good at explaining what it was and so on.
Yes.
But I think one needs to mention that there are other indicators, and that indicators are natural dyes that occur, you know, that we can find around us. I mean, in some instances, you can even use beetroot, you know, a squash beetroot as an indicator. You know, so I think that concept just needed to have been broadened. But I can understand that she wasn't really going to go into that very much. Perhaps at a later stage, she would introduce a concept of phenolphthalein and all the range
Turmeric
of
and
acidic indicators and so on, because that would be very important for them when it gets to titrations, where they have to do titrations and find endpoints. Yes.
Yeah. On the other hand, still on that note, I thought she merely had them explain those three because they were going to use them in class, which is an element that doesn't come out in many lessons. You know, you just provide the things that you use, like in a case, litmus, magnesium, calcium carbonate, and then you go, bang, and they go and do it. So for me, it was a strong point for her to make sure that they know what these ingredients that they will be using are. And what information they can get from them.
There was also a very good aspect of this lesson in that for the first part of the lesson the learners were following instructions, which is a skill in itself. They were very carefully going through each step of the procedure. The second part of the experiment was fairly open. They were given 2 unknown acids. Well, let's say 2 unknown substances, and they had to determine whether they were acid. And they didn't have a sequence, a set of instructions to follow. They had to work it out for themselves. I think that was a very nice design of the lesson.
Excellent.
Yes, I think it was a good lesson, and thank you. That's all we have for today. Thank you, Kanye. Thank you, Andrew. And thank you, Liz. Thank you, viewers at home. That's all we have for today. See you next time. Bye-bye.